It is night. Nothing can be seen except the very faint outline of rugged mountains to the northwest. The wind has died down, and the landscape in every direction seems to be fast asleep, even lifeless. Yet somewhere out there in the wilderness, a small enemy patrol is advancing toward one of our isolated base camps with all the skill, silence, and determination of superbly trained and indoctrinated guerrilla fighters. They are still nearly 3,000 meters away, but their presence has already been spotted by a solitary Allied soldier. In a matter of seconds, the soldier will have pinpointed their position on the map to within a few meters. He has identified them as a small group of men on foot, walking men, not running and not crawling. He will immediately get in contact with his battalion S2. Who will show the map coordinates of the reported position to battalion S3. When the S3, after checking, states that there are no friendly troops anywhere near this position, the S3 gets in touch with the artillery liaison officer and requests a fire mission. A few minutes later, the enemy suddenly finds itself in the center of artillery fire. The eyes which discovered the enemy patrol, the ears that heard their footsteps, and the locating capabilities which zeroed in on their position are all enclosed in less than 100 pounds of self-contained radar equipment, the ANPPS-5. This very sensitive combat surveillance instrument consists of two separate major assemblies. A receiver transmitter, which searches out and collects target signals, and a control indicator capable of providing both audio tones and visual target displays. To see the beginning of this successful mission, let's go back to the preceding afternoon as a ground surveillance radar section sergeant is directed by his battalion S2 to monitor a certain sector of the lowlands between our position and the border mountains. It is here, in this scrubby no man's land, that the latest intelligence reports indicate a rather sudden increase of enemy guerrilla activity. You must remember to maintain constant radio or field telephone contact between the radar site and the battalion headquarters. The PPS-5 used for this radar surveillance mission is generally stored in its convenient transport radar set case. Some components are strapped to the bottom side of the case cover. Other components are stored in their carrying harnesses for protection and immediate man-packing purposes. If the situation so demands, the entire system is designed to be man-packed in one carry by a three-man team. In this particular instance, however, the radar site was reached by military vehicle and man-packing has been unnecessary. An ideal radar site should have two different types of locations within 50 feet of each other. For line-of-sight surveillance purposes, the receiver transmitter must be placed so that its antenna will overlook the area without obstruction, and yet it should be concealed as much as possible. Your initial step after selecting a proper radar site will be to set up the tripod which supports the receiver transmitter. Under total blackout conditions, 2 men can install the entire ANPPS-5 system, meaning both assemblies, in 10 minutes or less. Remove the receiver transmitter from the carrying harness. Once this has been done, detach the scan drive box cover. The receiver transmitter, or RT box, houses the basic radar components and the scan drive box, which moves the antenna back and forth. Place the receiver transmitter on the tripod and secure it in place by tightening the wing screw on the tripod collar. Now, raise the column to place the receiver transmitter to the desired operating height. Release the end cap and remove the stowage bracket containing the feed horn, telescope, and ground pins. When attaching the feed horn, make sure you slide the flange all the way down to the coupling ledge. Otherwise, the radar will not operate properly. The control indicator should be located in a relatively protected, unexposed position, offering cover for the operator. When this unit is used, communication must be maintained from its location. At the same time, the reflector halves can be installed, making certain that the 3 locating pins on the antenna reflector line up with the 3 locating holes on the receiver transmitter. Each ANPPS-5 comes equipped with an external converter for possible use with an outside power source, such as a vehicular battery. But the customary power supply for the system is a 4-cell rechargeable battery which comes in its own self-contained battery box. Either of these power sources fit into the same receptacle on the back of the RT box. Make sure that the power switch is off, then remove the protective cover and plug the battery cable into the battery connector receptacle. The last item to be installed on the receiver transmitter is the telescope, which mounts on top of the RT box. The ground pins are used to secure the tripod feet to the ground as a safety precaution against high winds and irregular terrain. Place the stowage bracket back in the column and lock the end cap into position. Check switch settings for proper positioning and set the power switch to on. The receiver transmitter must be leveled prior to set operation. Leveling wheels beneath the antenna drive unit provide a means of setting the RT unit vertically straight. Now line up the center axis of the sector you intend to scan. Then regulate the Adjust Scan Orient knob so that the arrow of the indicator will point straight up to the center line. This centers the beam, which means that the antenna will scan an equal number of mils in either direction from its current position. For the time being, we should perhaps mention that this assembly can be used all by itself to monitor audio tones from moving targets, provided these targets are no closer than 50 meters from the antenna and no farther than 5,000 meters. But this capability is generally restricted to emergency situations in favor of the more versatile and longer-range control indicator. The control indicator connects to the receiver transmitter by a remote cable and is comparatively easy to place in operation. The visual radar signal indicators which distinguish this sophisticated assembly are these two oscilloscopes. When operating, the lower, horizontally rectangular A scope displays target echoes along the axis of azimuth of the radar beam as green-colored waveforms. The upper, square-shaped B scope, on the other hand, displays target echoes throughout the entire sector or area under surveillance as amber-colored blips. Both scopes cover a full range of approximately 5,000 meters at a time. In addition, both scopes have movable range gate markers for tracking possible targets and measuring their distances from the receiver transmitter. Since all these images are difficult to see in full daylight, the control indicator is provided with an optional viewing hood which fits over the scopes. The 50-foot remote cable, which brings both power and radar output from the receiver transmitter to the control indicator, has plugs at each end which snap lock into jacks on the assemblies. Allow enough cable slack between the control indicator and the receiver transmitter to permit the antenna to turn as far as it needs for scanning operations. Arrange the cable so that it is not kinked or raised where it can become a safety hazard. Once the two assemblies have been connected, there are several pre-operational checks and preliminary control settings to be made at each instrument. After which, its power can be turned on. To complete installation prior to operation, the radar set is oriented and collimated. This is to ensure range and azimuth accuracy. From here on, the system will be operated at the control indicator and the two operators will spell each other periodically. A few hours from now, the A and B scopes and headphones will detect, identify, and locate the guerrilla patrol and defeat its mission. To see how this will be accomplished, let's visit a staged demonstration where we will be able to observe the operation of the ANPPS-5 as various targets come within its range. It has been emplaced on Sentinel Hill, and the area of interest is a network of roads towards the base of Mustang Peak. The operator, therefore, makes the highest point of this prominent peak his zero azimuth and adjusts the receiver transmitter's scan orient indicator to the straight vertical position. Because the area being monitored is rather widespread, he decided to place the receiver transmitter in automatic scanning and sets his mode switch to 1600 mils. This means that the antenna system will scan a right-angle sector which extends 45 degrees or 800 mils to either side of the zero azimuth. Due to the considerable width of this sector, the operator sets his speed switch to 4 or 320 mils per second, the fastest of 4 possible scanning speeds. And because the area being monitored is from 7,000 to 8,000 meters away, he sets his range kilometer switch at 5-10. This means that the A and B scopes are now covering all possible targets within the area being scanned, whose distances from the radar are between 5,000 and 10,000 meters. These targets can be both fixed and moving. As you see here, the tremendous number of stationary targets such as trees, bushes, rocks, hills, and buildings create what is commonly called ground clutter. By flipping the video switch from normal to MTI, or moving target indication, the control indicator filters out all fixed target signals and displays only signals from moving targets within the 5,000 meter range band. Within this range, the operator can at the same time listen for audio signals from moving targets in any selected 600-meter segment whose position is determined by the range crank setting. The 600-meter segment is covered in 2 sweeps of the 300-meter range gate. When the antenna moves from left to right, the far 300 meters are covered, and during the right to left sweep, the near 300 meters are covered. At the present moment, there are no moving target indications on either scope. Then, without the knowledge of the operator, a parked Jeep suddenly starts moving along a distant road according to a prearranged plan. As soon as the sweeping radar beam reaches the Jeep's far-off position, a fairly prominent blip appears on the orange B-scope, accompanied by a corresponding but temporary wave shape on the green A-scope. Since the instrument is in automatic scanning, the operator decides to concentrate on the B-scope and his headphones. According to the vertical range kilometer scale to the right of the B-scope, the source of the yellow blip is about 7,900 meters away. And according to the horizontal scale just below the scope, its azimuth is approximately 420 mils to the right of center. To locate his moving target more precisely, the operator turns his range crank until the B-scope range gate marker is on the blip, and the target signal begins to be heard in his headphones. He then moves the antenna control switch to neutral, which causes the antenna to stop scanning and hold. Next, he puts this switch into either forward or reverse to pinpoint his target azimuth. To pinpoint his target range, he now throws his gate switch from wide to narrow, which immediately shortens the range gate from 300 meters to 40 meters. He turns his range crank in a clockwise direction until the target signal in his headphones is at its loudest. Then, the operator presses down the azimuth read lever and holds it. He is now able to get the precise target azimuth from the azimuth counter and the precise target range from the upper range counter. And from the audio tone in his headphones, the operator recognizes that this is the characteristic sound of a moving Jeep. This sound identifies a 3/4-ton truck. A 2.5-ton truck. A tracked vehicle. And at a closer range, a single soldier on foot. In each case, he identified his moving target by its characteristic audio tone. The audio signals from a group of men on foot is equally characteristic. A few hours after the incident of the enemy patrol, orders come to man-pack this ANPPS-5 to a more remote surveillance site. You must first of all turn off the power at both the control indicator and the receiver transmitter. It takes the radar team about the same time to disassemble the installation as it does to place it into operation. Disconnect the remote cable from the receiver transmitter and the control indicator, making sure that the protective covers are placed over the cable ends. Then stow the cable back into its pouch in the antenna reflector carrying pack. Disconnect the antenna halves. And slip them into their carrying packs. Be sure that their rounded ends are down and their thumb screws and locating pins are facing away from the carrying harness. When removing the feed horn, grasp it as near to its flange end as possible and place it out of the way. You should now take off the telescope and place it beside the feed horn. Then you can easily remove the battery box. Loosen the wing screw and remove the RT unit from the tripod column. After this, latch on the scan drive box cover. Next, clip the ground pins, telescope, and the feed horn to their stowage bracket. And slip it back inside the column. The receiver transmitter is placed in its carrying harness. Fold up the tripod and strap it to the antenna pack with its feet downward. In the meantime, the assistant operator has pulled the viewing hood from the holding strip on the control indicator and places it back into its cover. Secure the hood in place by buckling the hold-down strap. Put the cover back on the control indicator and lock it into place by closing the 4 catches, then insert it into its carrying harness. For man-packing purposes, one man will carry the receiver transmitter and battery. Another will carry tripod, antenna halves, power converter, and an additional battery. The third man will carry the control indicator and radio. In about 25 minutes, they will be at their new surveillance site. 10 minutes later, their ANPPS-5 will be completely reinstalled and ready once again to detect, pinpoint, and identify all moving enemy targets within its range.